Hey guys, welcome back. Today we are going to talk about corresponding parts of congruent triangles. Cpctc stands for corresponding parts of congruent triangles are congruent. Okay, so if we can show two triangles are congruent, then we can state that any corresponding parts are also congruent. Okay, so if we can just show that these two triangles are congruent, then we can make the statement that any corresponding parts within them are congruent. So what we are given is that segment YU is congruent to segment IU, and that segment OU bisects segment YI. So segment YI is cut in half by OU, and since YI is bisected, I know that those parts there, YO and IO, are congruent. Okay, now I also have a shared side. They share OU. By the reflexive property, I can say OU is congruent to itself. Okay, so with the given and then this reflexive property, I can say that triangle YOU is congruent to triangle IOU by side, side, side. Okay, now what I wanted to prove is that Y and I are congruent angles. Now that I know the triangles are congruent, I can say any set of corresponding parts is congruent, including angle Y and angle I. So I can say angle Y is congruent to angle I by Cpctc. Corresponding parts of congruent triangles are congruent. So here I know that segment PA and segment CK are congruent, and I know that PA and CK are also parallel to each other. Now they do share a side right here. So I can say by the reflexive property that segment KA is congruent to itself. So I do have two sets of sides congruent. Now on these parallel lines, so here's a line that is parallel to this line, and they are cut by a transversal. So this right here is a transversal. When two parallel lines are cut by a transversal, I know that alternate interior angles are congruent to each other. So angle PAK is congruent to angle CKA because they are alternate interior angles on parallel lines. Now that gives me enough for side, angle, side. So I can say that triangle PAK is congruent to triangle CKA by side, angle, side. And that means that any set of corresponding parts would be congruent. So PK and CA, this over here and this over here, these must be congruent. So segment PK is congruent to segment CA because corresponding parts of congruent triangles are congruent. Okay, so here we want to show that segment BC and DC are congruent. So what I know is that segment AC bisects segment BD. So it bisects BD. That means BD is cut in half. So BE and DE are congruent. I also know that AC and BD are perpendicular, so we have right angles in here. Okay, now if I just focus on this part over here and just pretend that no longer even exists, I could say that these two triangles share side EC. So by the reflexive property, I can say that EC is congruent to itself, and that gives me side, angle, side. So triangle BEC is congruent to triangle DEC by side, angle, side. And now that I know these two triangles over here are congruent, I can say that BC and DC are congruent segments because they are corresponding parts of congruent triangles. Segment BC is congruent to segment DC because corresponding parts of congruent triangles are congruent. Okay, now we've got one that's a bit more of a challenge. So in this figure, here's what I know. C is the midpoint of FG. So here on segment FG, C is the midpoint, so that means that CG and CF are congruent to each other. I know that AE is perpendicular to BG, so AE is perpendicular to BG. That gives me right angles right here. AE is perpendicular to FD, so AE and FD are perpendicular, so that gives me right angles right here. I know that AB is congruent to ED. AB is congruent to ED. Now, given all of that, I need to be able to show that angle A is congruent to angle E. So I want to get to the point where I know angle A is congruent to angle E. Okay, so based on everything I know, let's focus on this triangle here, BCG, and this one here, DCF. I have congruent angles here and a congruent side, and there's vertical angles. These vertical angles are congruent. So with that information, I can say triangle BCG is congruent to triangle DCF by angle, side, angle. Okay, now I want to work my way out to where I can get these top and bottom triangles congruent, so I can say that angle A and angle E are congruent. Okay, so to do that, I could say that BG and DF are congruent because they are corresponding parts of these two congruent triangles. So I'm going to say these two are congruent. So segment BG is congruent to segment DF because corresponding parts of congruent triangles are congruent. Okay, so here are my congruent triangles. I said these corresponding parts are congruent. Now I have right triangles here, and on those right triangles, I have two sets of congruent sides. Okay, but the angle I have is not between them, so I can't use side, angle, side. But since I have right triangles, I can use hypotenuse, leg to show that those two triangles are congruent. So triangle ABG is congruent to triangle EDF by hypotenuse, leg. And now that these two triangles are congruent, I can say that their corresponding parts are congruent. Specifically, angle A and angle E. Angle A is congruent to angle E Why? Because corresponding parts of congruent triangles are congruent.